In this screencast, I like to explain some of the advantages of using screencasts to introduce and explain an equation as opposed to having an equation presented in the textbook and then having text below the equation explaining the various terms in the equation. And so there are at least three significant advantages to doing this. One is that we can use color to separate out different terms. The other is we don't have to introduce the equation all at once, so we can sequentially introduce terms. The idea is we can introduce the term and explain it as we're introducing it, rather than presenting it all at once and having text below. Other is we don't necessarily have to be linear. We don't have to go from the top of the page to the bottom, but we could have an equation. For example, if we have this equation, which we'll use in our example, we could have things off this way and over here. So we use this equation as an example of how can we take advantage of screencast in introducing, describing properties of an equation. So dg, which is the change in Gibbs free energy, differential change, is equal to minus the entropy times differential in temperature plus volume. There's a specific volume and a differential in pressure. We can look at, because this is an exact differential, we can write this term. What we're going to do is write it here as the change in the Gibbs free energy with respect to temperature, keeping the other variable constant. And then we're going to do the same thing for the volume. We're going to write this as the change in the Gibbs free energy with respect to pressure, keeping this variable temperature constant. And then one of the things that we can do is the property of this exact differential. We can differentiate, so we're going to differentiate this term with respect to the other variables. So now we'll differentiate with respect to pressure while keeping temperature constant. And we're going to differentiate this term with respect to temperature, keeping pressure constant. And then what we're going to say is these two terms are equal. And they're equal to the second derivative of the Gibbs free energy respect to temperature, respect to pressure. The order of the differentiation doesn't matter. And so therefore we can write it either way. This is what makes these two terms equal. The other thing we can then do is substitute this derivative of pressure. Well, this term in brackets is minus entropy. That's derivative at constant temperature. And this term, the derivative of temperature, is derivative of volume respect to temperature at constant pressure. And this we would write as minus the derivative of entropy respect to pressure at constant temperature. And so these two terms are equal. And this is one of the Maxwell relations that we can derive. They have some advantages in thermodynamics, but the point here is that we can relate terms more easily, and we can introduce the terms sequentially to make it easier for students to see where these terms came from.